Hello there, my fellow mainframers and computer performance analysts. Recently I put up a video about the concept of throughput measurements used to help quantify performance. Since that video was published, several viewers have sent me emails asking me to help them better understand two of the throughput measurements I briefly discussed in that video. The measurements of interest are external throughput rate and internal throughput rate. In this video, I will discuss more about these two critically important workload throughput measurements and how they could be used to quantify performance improvements and degradations. Hi there, I am Peter Enrico of Enterprise Performance Strategies. My team and I are here to help you get great workload performance while optimizing the usage of the system resources in the mainframe environment. Our education and our Pivotor software are geared towards helping you get better performance results and faster. We created the Mainframe Performance channel to teach you how to do what we do. Now, if you're new here, click that subscribe button, and any of the references I give in this video, I'll be sure to link in the references below. Have you ever made a change to your mainframe environment and then wanted to know if that change resulted in a performance improvement or degradation to your workloads? If so, then to figure this out, we use two of the most important workload throughput measurements. What are these measurements? They are external throughput rate, which is known as ETR, and internal throughput rate, which is known as ITR. Now, the best way to explain both ETR and ITR is by example. The example I'm going to give you in this video is a variation of a classic example that can be found in IBM's Large System Performance Reference document. I have listed the reference to this document in the links below. The example is as follows. Say you have a workload composed of a fixed number of transactions. Let's say the workload is composed of 10,000 units of work, and for the purpose of this video, we'll use the term transactions. Let's say you are making some change to the workload or the environment, and after you make the change, you or maybe your manager wants to know if the change was a positive performance improvement or resulted in some negative performance degradation. Now, what kind of change are we talking about? Well, for the purpose of this explanation, it doesn't really matter what the change is. It could be a processor upgrade, it could be a parameter change, a change to the software stack, a change to an application, or whatever. The point is that something is different and you want to know if that change had a positive or negative impact to those 10,000 transactions. So before you make the change, you run the 10,000 transactions and you find that collectively they take 2,056 elapsed wall clock seconds to execute from the start of the first transaction to the end of the last transaction. You then make your change and you rerun and remeasure those same 10,000 transactions again. Only this time you find that the same 10,000 transactions now takes 1,556 seconds to execute. Now visually, I'm showing those timelines here. Now, just looking at this diagram, it appears that the change was an improvement. We can easily see that the elapsed time of the workload decreased. In fact, we know in the before scenario, the workload took 2,056 elapsed wall clock seconds to run, and in the after scenario, it took 1,556 elapsed wall clock seconds. Well, a measurement known as the external throughput rate can be used to help us quantify this change. As I mentioned, the acronym external throughput rate is ETR, and it is a measurement that focuses on the environment's capacity. The formula for ETR is listed here. The ETR is the number of units of work completed divided by the number of seconds in the measurement interval that it took to complete these transactions. Another term for ETR is transactions per second. But I need to be specific here. It is the number of transactions per wall clock second. Why wall clock seconds? Because we are measuring the throughput as a function of the system's capacity. And when I say the system's capacity, I'm referring to the processor, the I/O subsystem, the storage, the operating system, external resources, etc. Now, in this example, The before ETR is 10,000 transactions divided by 2,056 seconds in the interval to give us 4.86 transactions per second. The after ETR is 10,000 transactions divided by 1,556 wall clock seconds to give us 6.3 transactions per second. So as you can see, in the after case, the system is able to execute more transactions per second for this workload. In fact, we can take the ratio of the after ETR to the before ETR, and we find that there was a 32% increase in the throughput. By the way, this is known as the external throughput rate ratio, and the formula is shown here. Okay, so far things are looking pretty good, and hopefully you have a better understanding now how ETR could be used as a way to quantify the improvement or degradation of a workload's throughput based on system's capacity. What about the internal throughput rate? The acronym for internal throughput rate is ITR, and I will admit to you that ITR is one of my favorite computer performance formulas and measurements. To explain ITR, let's look at this timeline again, and once again I've shown it here, but this time I am showing you a breakdown of the time that for the transactions into CPU time, I/O time, wait time, and other times that typically make up the elapsed time of a workload. In the before case, our 10,000 transactions took 2,056 seconds to complete. But note that the CPU component of the elapsed time was 925 CPU seconds. In the after case, our 10,000 transactions took 1,556 seconds to complete, but note that the CPU component of the transactions increased to 1,090 CPU seconds. The key point to note here is that although the elapsed time of the workload went down, in this particular example, the CPU component went up. It is the ITR formula that we can use to quantify this CPU component of the workload. As I said, ITR stands for internal throughput rate, and the formula is listed here. It is the number of units of work completed divided by the CPU seconds it took to complete those units of work. Now the key point here is we use the CPU seconds instead of the wall clock seconds. And why do we do this? The reason is to put focus on the CPU component of the workload and not the entire system capacity. In our example, the before ITR is 10,000 transactions divided by 925 CPU seconds used to complete those transactions. So the before ITR is 10.81 transactions per CPU seconds. The after ITR is 10,000 transactions divided by 1,090 CPU seconds, or 9.17 transactions per CPU seconds. Now we see here that in the before case, the system is able to execute more transactions per CPU second of this workload. In fact, if we take the ratio of the after ITR to the before ITR, we find that there was a negative 15.17% degradation. And by the way, this is what's known as the internal throughput rate ratio, and the formula is listed here. And to be fair, the ITRR is the foundation of IBM's LSPR measurements for processor sizing. Only the ITR formula used is the units of work divided by the processor busy, which is a variation of what I'm giving you. In this formula, processor busy time is used since when using ITRs to evaluate a processor upgrade, you need to include the processor time, but you also need to include all the system time. And that's why the IBM LSPR uses processor utilization. I will be discussing ITRs and ITRRs more when I discuss IBM's LSPRs in a separate video. Now let's go back to our basic question. Was the change we made a performance improvement or a performance degradation? Well, now we see the answer to this question is, it depends. In particular, the answer is dependent upon who we ask and what they are looking for to achieve. For example, if we are asking the customers of the workload, I would think that they would be pretty happy with the change because now they are getting their workloads done faster. They are seeing a 32% improvement in their transaction throughput due to a higher number of ended transactions per second. But if you ask the management or the financial people or even the capacity planners, they may not be as happy because of the decrease of 15.17% for the number of transactions per CPU second. Another way of looking at it is the same workload is taking more CPU to complete per transaction. This in turn may result in an increase in process utilization or in the software bills. We would need to do some further analysis to figure this out. We certainly cannot say if the change is good or bad at this point. We can only say that there was an improvement or a degradation. There was an improvement and a degradation, actually. And this is why it's always important to understand the purpose of a change. The point is, whenever you make a change, you should calculate out both the before and after ETRs and the before and after ITRs, and then make an evaluation of the change relative to what you were hoping the change would achieve. Oh, one more thing I want to say before I conclude this video. When you are measuring your workload, you probably don't have a fixed number of transactions like in my example. Instead, your workloads, whether they be batch or kicks or IMS or DEDF or whatever, are continuously running and continuously executing. This is okay. The formulas are all the same. ETR is going to be the number of transactions per wall clock second, and ITR is going to be the number of transactions per CPU second. So as long as you have some number of transactions, the measurement of the interval, the number of CPU seconds, or the processor utilization for your workloads, you should be able to calculate all of this out. And I should point out that there are additional considerations when using ETRs and ITRs, but I will cover those in a separate video. For now, I just want to get across the point or the basic concepts of these two important workload throughput measurements. So that's it from me, Peter Enrico of Enterprise Performance Strategies in Pivotor, and I want to thank you, my fellow mainframers and computer performance analysts, for watching this video. Please consider hitting that subscribe button, and if you like this video, please let me know by hitting the like button. Take care, have fun, enjoy the day, and I'm looking forward to another session with you.